Welcome to our fact channel. Our channel has well-known, little-known, and unknown facts. Today we will discuss facts about Jupiter. Let's start. Jupiter is the largest planet in our solar system, with a diameter more than 11 times that of Earth, and it contains more than twice the mass of all the other planets combined. Jupiter's Great Red Spot is a massive storm larger than Earth, which has been raging for centuries, making it one of the most iconic features of the planet. Jupiter has four large moons known as the Galilean moons Io, Europa, Ganymede, and Callisto, which were discovered by Galileo Galilei in 1610 and are some of the most fascinating objects in the solar system. Jupiter has the strongest magnetic field of any planet in our solar system, creating a vast magnetosphere that extends millions of kilometers into space and interacts with its moons and surrounding environment. Although not as prominent as Saturn's rings, Jupiter also has a faint ring system composed of dust particles, which were discovered by the Voyager 1 spacecraft in 1979. Io, one of Jupiter's moons, is the most volcanically active body in the solar system, with hundreds of active volcanoes that spew sulfur and other materials into space. Europa, another moon of Jupiter, is believed to have a subsurface ocean beneath its icy crust, raising the possibility of it harboring life in its dark, hidden depths. Ganymede, the largest moon in the solar system, has its magnetic field, making it the only moon known to have one, which is likely generated by a liquid iron core. Callisto, one of Jupiter's moons, has one of the oldest and most heavily cratered surfaces in the solar system, indicating that its geological activity has been minimal for billions of years. Jupiter is primarily composed of hydrogen and helium, similar to a small star, with trace amounts of other elements such as water, methane, and ammonia. Jupiter's powerful gravity significantly influences the orbits of other objects in the solar system, and has helped shape the architecture of our cosmic neighborhood. Jupiter has the shortest day of any planet in our solar system, with a rotation period of about 9.9 hours, resulting in its distinctive banded appearance and rapid atmospheric changes. Jupiter likely has a dense core of rock and metal surrounded by a layer of metallic hydrogen, with an outer layer of molecular hydrogen and helium gas extending into its vast atmosphere. Jupiter has a group of asteroids called the Trojan asteroids, which share its orbit around the Sun and are located at stable points ahead of and behind the planet. Jupiter has several small moons that orbit within its magnetosphere, including Amalthea, Thebe, and Metis, which interact with its magnetic field and plasma environment. Jupiter's ring system consists of four main components: the halo ring, the main ring, the Amalthea Gossamer ring, and the Thebe Gossamer ring, which are composed of dust particles ejected from nearby moons. Jupiter's atmosphere is divided into several distinct layers, including the troposphere, stratosphere, thermosphere, and exosphere, each with its own unique properties and dynamics. Jupiter's powerful magnetic field generates intense auroras near its poles, similar to Earth's northern and southern lights, but much larger and more energetic. The Galilean moons of Jupiter, especially Io, exert gravitational forces on each other, causing tidal heating, orbital resonances, and other dynamic interactions that shape their orbits and geological features. Jupiter's atmosphere is marked by dynamic weather patterns, including belts and zones of alternating winds, massive storm systems, and atmospheric disturbances that can last for weeks or even months. The Trojan asteroids in Jupiter's orbit are divided into two main families: the Greek camp, located ahead of Jupiter, and the Trojan camp, located behind it, which have distinct orbital characteristics and compositions. Although relatively small, the Galilean moons of Jupiter have thin atmospheres composed mainly of oxygen, hydrogen, and other gases, which interact with their surfaces and surrounding space environment. Jupiter exhibits features commonly found on exoplanets, such as hotspots, cloud layers, and variable atmospheric compositions, providing valuable insights into planetary formation and evolution beyond our solar system. Jupiter's gravity assists have been crucial for spacecraft missions exploring the outer solar system, enabling faster trajectories and fuel-efficient maneuvers, including the Voyager and Juno missions. The Trojan asteroids in Jupiter's orbit are believed to be remnants of the early solar system, possibly originating from the same region as Jupiter during its formation and later captured into their current orbits. Jupiter's upper atmosphere contains clouds of methane ice crystals, which contribute to its reddish-brown coloration and play a role in the planet's complex weather and atmospheric chemistry. Jupiter's magnetic field is tilted relative to its rotation axis and offset from its center, creating a magnetic anomaly known as the Great Blue Spot, which influences its auroras and radiation belts. Beneath its molecular hydrogen atmosphere, Jupiter has a layer of metallic hydrogen, a highly conductive fluid state of hydrogen compressed to extreme pressures found in the cores of gas giants. Io's volcanic plumes erupting from its surface can reach heights of hundreds of kilometers and release vast amounts of sulfur dioxide and other gases into space, contributing to Jupiter's magnetosphere. Approximately once every 175 years, Jupiter, Saturn, Uranus, and Neptune align in a rare configuration known as a grand conjunction, with significant astronomical and astrological implications. Jupiter's cloud bands and storms are driven by complex interactions between atmospheric gases, heat from the interior, and the planet's rapid rotation, producing intricate patterns and vortices in its atmosphere. The gravitational interactions between Jupiter and its Galilean moons generate tidal forces that heat their interiors, leading to geological activity, subsurface oceans, and volcanic eruptions on moons like Io and Europa. Jupiter's intense magnetosphere interacts with Europa's subsurface ocean, inducing electrical currents that could generate heat and maintain a liquid water environment beneath its icy crust, raising the possibility of habitability. Jupiter's powerful magnetic field traps charged particles from its magnetosphere, channeling them into its polar regions and producing intense auroras, which are observed in ultraviolet and infrared wavelengths by spacecraft like Juno. The Trojan asteroids in Jupiter's orbit are trapped in stable regions known as Lagrange points, where the gravitational forces of Jupiter and the Sun balance, allowing them to orbit in quasi-stable configurations for millions of years. Jupiter's magnetosphere is filled with plasma waves and oscillations driven by interactions between its magnetic field and the solar wind, which are studied by spacecraft like Juno to understand its dynamic environment. Comet Shoemaker-Levy 9's collision with Jupiter in 1994 provided a rare opportunity to study the dynamics of planetary impacts and the composition of Jupiter's atmosphere, leaving scars visible for months after the event. Jupiter played a crucial role in the early solar system's evolution by deflecting asteroids and comets away from the inner planets, preventing catastrophic impacts and shaping the distribution of material in the solar nebula. Jupiter's stratosphere contains layers of haze composed of complex hydrocarbons and other molecules, which scatter and absorb sunlight, creating the planet's muted coloration and atmospheric features observed by spacecraft. Each of Jupiter's Galilean moons has unique characteristics, such as Io's volcanic activity, Europa's subsurface ocean, Ganymedes' magnetic field, and Callisto's ancient surface, offering diverse targets for future exploration and scientific study. Jupiter's powerful magnetic field directs charged particles from its magnetosphere into its atmosphere, generating bright auroras near its poles that are larger and more energetic than Earth's, visible in ultraviolet and infrared wavelengths. Jupiter's faint ring system is thought to be formed by dust particles ejected from nearby moons and micrometeoroid impacts on Jupiter's atmosphere, influenced by its magnetic field and orbital resonances with its moons. Jupiter's Trojan asteroids are divided into two main camps, the leading Greek camp and the trailing Trojan camp, named after characters from the Trojan War, reflecting their distinct orbital characteristics and dynamical histories. Jupiter's dense metallic hydrogen core generates its powerful magnetic field, which interacts with its rapidly rotating metallic hydrogen layer and outer molecular hydrogen atmosphere, producing its complex magnetic field and auroras. Jupiter's migration during the early solar system's formation may have triggered the inward migration of other giant planets, influenced the formation and distribution of smaller planets and asteroids, and shaped the architecture of the solar system we observe today. The Galilean moons of Jupiter are in orbital resonances with each other, meaning their orbital periods are related by simple integer ratios, stabilizing their orbits and leading to gravitational interactions that affect their orbits and geological features. Jupiter's magnetosphere interacts with the solar wind and plasma from its moons, generating plasma waves, currents, and oscillations that affect its radiation belts, auroras, and magnetospheric dynamics observed by spacecraft like Juno. Thank you for watching our video Interesting Facts about Jupiter. Subscribe, put a like, and to new interesting facts.